folks. All right, this time around I want to get into talking about functions and about libraries, and we'll look at a few of the common libraries out there and some of the routines that are available to us, and yeah, maybe get into some little samples and a little bit of code and see how we go. All right, so we've seen a few examples already of the typical use of libraries that contain pre-built code. So we've looked at the cstdio, we've looked at iostream, we've looked at iomanip, and we've used some bits and pieces from each of them. So each of the libraries can contain a whole slew of different things. It can contain definitions for data types, definitions for constants, definitions for functions, a variety of pre-existing routines. So there's a whole bunch of different things that can be created in these things. And when we hash include a library, it allows our program to make use of all those different defined items. So the syntax that we've been using so far has been for pre-written libraries, built-in libraries, if you like. And so these use that syntax less than, the library name, and the greater than. We will later look at the syntax for building and including libraries of our own, but we'll get there later. So there's a whole slew of different common libraries that we'll make use of. So cstdio for standard input and output, iostream and iomanip, as we've seen for output with cin and cout, the cmath library, a cstring library, CCtype, cstdlib, string, climits, cfloat, a whole slew of them that we're going to make use of. So we'll try and introduce these and talk about the most common routines in them as we go through the semester. So, in terms of functions, so a function is basically just a named collection of code that we can run by using the function name. So we've seen this already with things like printf and scanf. Printf and scanf do a bunch of different things when we call them. So this is the idea of a function. Somewhere somebody has gone off, written a bunch of code, slapped the name printf on it, and we can then, if we include the appropriate library, run the function simply by calling it. So to use a function, to run a function, it's said we call it from wherever we are in the program, in the main routine for instance. We use its name, and then in those round brackets we pass any data values that it needs to work on. So these are called parameters or arguments, and as we've seen, we put each of these values in separated by commas. So for this example, our printf, where we're passing a format string with %f in it, and we're passing the variable x, the parameters or arguments are that first string and the x. So when we're talking about parameters, we're just talking about the data values that we're sending to the function when we call it. And again, we've seen a variety of different examples. If we look at a typical little program that we've written so far, in our first call to printf, we've got this string, enter an integer. So that string is, in this case, the one parameter that's being sent to printf. Then we've got our scanf, where we pass the format string, and we pass essentially the memory address of where it's going to wind up. So again, we've got two parameters that we're passing this time. And then again, the second printf, we're passing the string, and we're passing the value to be embedded in it. So it's just the collection of arguments or collection of parameters that we're sending to the function when we call it. All right. Now, what we haven't talked about so far is that in addition to whatever else they do, a function can also send back a value when it finishes, return a value. So quite a few functions do some form of computation while they're running, and then when they're done, they send back a value that the program can then use. So this is, again, in addition to anything else the routines might be doing. We'll talk about printf and scanf actually having return values, information that they can send back once they complete, in addition to the input or output that they're actually performing. So maybe a nice obvious example is something like a square root function. So for a square root function, it's sqrt, and this is in the cmath library. As a parameter, we pass it the thing we want to take the root of. So if I want to know what the square root of y is, I call square root of y, We'll call square root, pass it y as a parameter, and it goes off and computes that, and when it's finished, it returns the value. So it figures out what the root of y is, and essentially gives it back, if you like, and once it gives it back, once this function call completes, we can use that value. So here what I'm going to do with it is assign it to x. So this is going to go off, compute the square root of y, and then store the result in x. So if we were to maybe give this a quick try here, let's make x a double just for the sake of argument here. So we'll say enter a number. We'll have to include the cmath library since that's the one that's got square root in it. So we're reading a number. The format string for doubles is LF, right? Long floats. So we're getting them to enter a number, we're storing it, and then let's compute the square root. So we'll have a variable to hold the square root, and we'll say the root is, and we'll call the square root of x in this case. So this is going to go off, compute the square root of x, give it back, and we'll store it in our variable root. So let's change this a little and say the root of %lf is %lf. And so the root of x is whatever our root is. So hopefully this will go off and compute our value. Let's do a quick compilation here. Hey, it actually worked. So let's try simp. Enter a number, so I'll try 16. And it says the root of 16 is 4. So hey, actually got the results we'd be expecting. And again, it's treating everything as doubles in this particular case. Now, when it returns the value, we can use the value kind of right where the return state, right where the return comes back. So it comes back to wherever the function is called. So I can embed things like our function calls in bigger expressions. So I can say something like this, compute the square root of x plus 4, right? So it's going to compute the square root and then use that value as part of this bigger expression. Or I can go through and maybe add a second variable. Let's enter 2 numbers. And we'll read and store them both. We'll read and store 1 in x and 1 in y. And we'll compute the sum of the roots. So we'll compute the square root of x plus the square root of y. Sum of the roots is, and so I'm just going to get a little bit lazy here and just put the one value. And so now we're going through, getting 2 values, reading them both in, and then we want to compute the square root of one plus the square root of the other. So we're just calling the function once to get the square root of x, and another time to compute the square root of y, and adding together whatever the results are. So you can build up these expressions. And let's just check and see if that worked. Compiled okay. So let's try 16 and 25. So yeah, comes up with the root of 16 should be 4, root of 25 should be 5, so 9 does appear to be correct. All right. So in order to use a function correctly, we have to know its name, we have to know which library it's in, we have to know what data values we're going to pass, what parameters it expects, and in what order, right? If I have a function that's going to raise the first parameter to the power of the second parameter, then I've got to pass them in the right order to get the results I expect. And we need to know what kind of data it's going to give back, if any. It's actually, some functions can run and not return a value. So we need to know what type of data it's going to return. Now, what happens is, whenever we call a function, the caller, the main routine for example, pauses while the function goes off and does its thing, and once the function returns, then the caller picks up where it left off. So if we think of the example that we just took a look at here, when we're going through this expression, it's going to say, oh, okay, go off and compute the square root of x. So it goes off and does that and effectively gives back the value and remembers that value here for a moment. And then we call, okay, let's call square root again on y, and it goes off, does its computation, and comes back. And then once we've got both values back, the addition can complete and actually work out what the sum of the two values is. But we've got this notion that whenever we call a function, the calling routine, in this case the main routine, sits and waits for that function to come back with an answer. All right, printf and scanf actually have return values that we just haven't made use of yet. So in the case of printf, while it's running and while it's printing out whatever it's printing out on the screen, it actually keeps a count of how many characters it displays on the screen. Right? So how many characters the user actually sees. And it returns that count when it's finished. So in this particular example, I'm going to go through and say, okay, well, let's try a simple printf. We'll put a value in a variable x, and then we'll print a little bit of text, x is, and we'll have the value of x embedded there and a new line. And so this printf goes off and runs, and it prints x is 3 in this case, followed by a new line. And then it returns a count of those characters, right? So you've got one for the x, one for the space, one for I, one for s, one for space, one for 3, and one for new line. So it's going to return a value of 7. So in this case, the whatever variable we have over here is going to get assigned a value of 7. So printf returns a value as well, and we've just ignored it so far. Similarly, scanf returns a value. In the case of scanf, it's not a count of how many characters it read in, it's actually a count of how many variables it successfully filled. So if I have something like scanf, %d /%d, and then an x and a y, then it'll return either 0, 1, or 2. 0 if it didn't manage to successfully read anything into x, 1 if it managed to read something into x but not anything into y, and 2 if it managed to read something into x and something into y. So we can make use of this a little later on when we get into error checking. But again, printf and scanf, in addition to the I/O that they're doing, also go through and return a value to us when they're done. So just kind of a quick introduction to a handful of the different cmath functions that we'll be making use of. So the cmath library, again, contains functions to do things like compute the square root, to compute x raised to the power of y, to compute the absolute value of a number, so the absolute value of x in this case. The f is there for floating point absolute. Ceil of x returns the ceiling of x rounded up. Now these aren't actually changing x, they're just saying, okay, well, if x is 3.4, then we'll return, or if x is 3.4, we'll return 4. If x is 3.1, we'll return 3, right? Or pardon me, 4 again, good grief. The floor is rounding down. And there's also one for round that does the, round by 0.5 up or whatever. Cosine, sine, tangent, or tan for tangent, log. Again, a whole slew of different common math functions. And yeah, we just need to know what the name is and what order to pass the parameters in. And I believe by default, all of these expect the parameters to be doubles. If you pass a floating point, then it basically just treats it as just converts that float to a double to do the computation. So you will get the correct value back. For integers, again, if you pass something like the integer 4 as the square root, then it'll just say, okay, well, compute the square root of 4.0. So we can go through and use most of these math functions pretty easily. A couple of other libraries, maybe we'll talk about CCtype just briefly as another example. So this is used for working with characters when we want to analyze character data. So if we ask the user to type in something, we might wind up looking at the characters and going, okay, well, I expected them to enter a number. Can I check and see if the characters that they entered were all digits? Or I expected them to enter a name. Can I check and see if all the characters they entered were alphabetic? Or if I want to check and see if the next thing that was typed in was some kind of white space, tabs or new lines. If I want to go through and convert characters from uppercase to lowercase or the other way around, or check if something's punctuation, there's a whole slew of different character analysis and character manipulation functions that are available in this CCtype library. So again, none of these actually change the character that you're passing. They just look at it and return a result based on whatever that is. So something like toUpper that gets the uppercase equivalent of whatever's in X. So if X was a lowercase a, it would return an uppercase a. So it doesn't actually change X, but it gives us the correct result as a return value. So there's a whole slew of these different functions. And again, what will happen is as we go through the term, we'll look at more and more different functions that are useful for whatever problem we're trying to solve, and which library they're in, and what parameters they expect, and what they return. All right, I think in the next session we'll go through and just play with a whole bunch of programming examples with different functions and just get kind of a little more practice with our programming skills. I think that's where I will leave this one.